Okay, let's do this. Chain rule. What? Why so big? All right. When do you use chain rule? The chain rule is applied only if you have function within the functions. So you only apply when when you have function within the function. What do I mean by function within a function? This is actually known as a composite function. I don't know if you guys ever learned from composite function before. It looks like this: h of x equal to f of g of x. That means g of x is within f of x.
And it can also be f circle gx, right?
Yeah, f circle g of x. Yeah, that's gonna be like another notation. This is actually another notation of that. But yeah. Now, for what I told people, like standard, when I see this, it usually is a parenthesis with power other than 1. Power other than 1. So usually something like, say, if 2x plus 1 to the first power, you don't have to do anything. But to the half power, you can do a chain rule. Or to a 1/3 power or negative 1/3 power. So it's other than 1. So something like, long as this number is not 1. So this is not 1. Usually I will do a chain rule. Even 1.5, even 2/3, even, whatever. So let's talk about what's composite function first. So you guys know, if I have f of x equal to 2x minus 1, and g of x is equal to 3x squared minus 1. So what is f of g of x?
2 times 3x minus 1.
Yep. So instead of write down 2x minus 1, it's going to be 2 parentheses minus 1. You're going to replace that x with 3x squared minus 1. Does that make sense? So that's just a composite function. Now, what if I ask you a question backwards? I say, hey, if I have this h of x is equal to 1 over x plus 2, and h of x is equal to f of g of x, can you tell me what is f of x here? And what is g of x here? So that means I'm asking question backwards. Yep.
Is g of x x plus 2?
G of x is x plus 2. Good. Yep. Does that make sense? Because I plug in g of x into f of x, I got 1 over x plus 2. Got it? Great. Moving on. What if this h of x is equal to square root of 2x squared minus 3x? What is and the h of x is equal to f of g of x? Can you tell me what is the f of x and what is g of x? Kaiwan? What do you think, Kaiwan? No? Catherine, what do you think? Perfect. Perfect. You guys are geniuses. We're gonna move on. This is just algebra. This is pre-cal. You learned this in pre-cal. Right? Moving on. And we say, okay, well, Great. Now, what do you mean by doing chain rule? Well, a chain rule is going to be like this. So what if I have this h of x, right? And I have something to the, I don't know, 2x minus 1 to the 10th power. And I say, hey, take a derivative of this. And you're going to be like, Mr. Ye says, always do algebra first. So we're going to expand 2x minus 1 times 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 10 times. And then Madden give me that look, says, I don't think he want me to do that, right? Because that's going to require Pascal triangle. In order for you to expand that Pascal triangle to the 10th power, it's probably take 25 minutes if you are good. If you are good. If you are bad, then it's probably going to take 50 minutes and you got a wrong answer. So then there's got to be a new way to take a derivative of this. So what will be the f of x here, and what will be g of x here? Now, what will be that? X to the 10, good. 2x minus 1, good. So now we're going to teach you a new rule. So we're going to write this chain rule on this side. If you take a derivative of f of g of x like this, it's always equal to f prime of g of x times g prime of x. And you're like, what do you mean? Have you guys peeled onion before? I never peeled onion in my life because I hate onions. But I heard onions like a layer, right? As you peel outside the layer, the inside layer is still there, right? And you peel it again, there's more inside there. Also, have you guys eating like, Maddie look like a person like lollipops, right? Do you like lollipops? Yeah. Okay. Do you know how those lollipop has layers? Like outside is the sugar coating or the sour coating, and inside is the sugar coating, and the most inside is a bubble gum. Remember that? I love those. Like, so pretty much the same. You're gonna consume the outside layer first. The inside layer is still intact, and then you consume the middle layer, and the inside layer is still intact, and then you finally get to eat a bubble gum. Pretty much this is the same idea. It's that in this question, there's only 2 layers. I'm going to show you what are those 2 layers is. The first layer is right here, which is x to the 10. The second layer is there, 2x minus 1. Am I going too fast? So remember, this is going to be taken derivative. If you look at this, it's f prime of g of x. So that means h prime of x. If I take a derivative of x to the 10, basically it's 10 something to the 9. Does that make sense? Because that's just x to the 10. But except inside is the inner layer, which is that's a bubble gum. Am I going too fast?
You're not going too fast. You need time to think about
it. And then what I'm going to do is I'm going to take a derivative inside layer now. So I got to chew the bubble gum, and that'll be 2.
Yeah, wow.
Because g prime of x. And that answer is going to be 20 to the 2x minus 1 to the 9th power, and that's h prime of x, and that's so easy.
And you don't need to simplify it.
You don't need to simplify any higher than that because you always leave in factor form. And that's it, you're done. What? Because take a derivative of x to the 10 is going to be 10x to the 9. So then the inside is not x. The inside is 2x minus 1. It's a bubble gum. Is that okay? Yes? It's not as scary as that sounds. But chain rule is going to be root of all derivative, okay? It takes about 10 to 12 seconds. So 10 to 12 points on AP exam. So I'm gonna give you a question. I say, hey, can you take a derivative of this? So I'm gonna call this f of x, but it's obviously some function within some functions. So it'll be 2 minus 3x squared to the second power to the third like this. I say, hey, I want to take a derivative of this and just using a chain rule. Now, why do I know it's chain rule? Is something parenthesis to other power than 1. But you had to make some algebra manipulation first.
Powers of 1 over.
No.
You would just add 1/3 to the power.
Oh, let me give you some power. Do you know this rule? It's called definition radical.
Somewhere I don't know. Putting like over in the inside. So it would be
Is that 2 or 3?
God, 2 minus 3 is.
Oh, just take it from it.
Is my face still swollen? It's less than yesterday or no? My own iPhone doesn't even recognize me.
Yeah. How come I don't reply to any of these 3 kids?
I don't.
Yeah. And they were like, are you doing okay? And all you message reply back is, my face ID isn't working.
Yeah. Because they couldn't even recognize me. So my own banking does like rejected me. Like it's like we don't accept this person because we can recognize you. No, I was teaching from 5 to 9 yesterday. Huh? Why do I have what? Yeah, why is that? That's gross. Why do I have that?
So this rewrite is like we're kind of
No.
It's not mine.
Oh, no way. I had no idea. I thought it was
The grossest thing I ever seen in my life in school. Fuck, I'm live streaming. No. Okay, so I'm gonna rewrite this right to a 2 minus 3x squared to the which power? 2 third power. Good. Shh. Now there is a outside layer right here, and there's inside layer, right? So if I take a derivative, it's gonna be 2 third of the inside layer still intact. It's not changing. It's negative 1/3. Is that okay? Now let's take a derivative inside, which is what? Don't forget the inside layer, because inside layer is very important. So then I can simplify this 3 and this. This is gonna get me -2. I think it's gonna be -4x, right? Times, and I'm gonna move this on the bottom, so it'll be 2 minus 3x squared to the 1/3. And that's my final answer here. Chase is cooking. Right, Chase? Yeah.
Would you rather leave it to the 1/3 or put it?
1/3 is fine. I don't like radicals much because I usually figure out with a rational exponent. But you gotta understand sometimes the answer choice may be cube root. Okay, so the next question is this one.
Wait, can I see the steps from the left?
Why you eye so bad? Do you need glasses?
I already have glasses.
I think it's I think it's a 7 because
It's a 7. Thank you. Somebody recognized my handwriting. I hate that word, gaslighting. Huh? Like, who's using gaslighting? Such a weird word.
And you're just using words you don't know how to use. Did that teach you that word?
Stop. No.
That's scary.
Like, who teach you how to use that word? Now remember, this is a constant on the top situation. This is a situation I usually ask you to avoid quotient rule. You could get done. Can somebody take that thing? That's so weird. Why is it on my table?
Okay, why would you go? Why you throw it away?
Yeah.
What if a girl just comes up to you and asks you for a tampon?
So yeah, you're so thoughtful. Like,
I don't even. Not mine.
You don't menstruate? What?
I do.
you should do like a. You should do an unboxing video.
Huh?
You should do an unboxing video.
You know, like your water bottle, like when you stick a pencil in, you can put the tampon in top.
No comment. I can't say anything. All right. So, how much time I have? Oh, good. All right. So I'm gonna rewrite this. How do I rewrite this? Did you do this? Did you rewrite it before you can take a derivative? Chain rule. So remember, there's a two layer. One layer here, second layer here, right? So then that's going to be -7 times -3 times 2x minus 3 to the -4 power. No, 7's not in the layer. The 2 is going to be outside. Don't forget that 2. So that is equal to 42 over 2x minus 3. Wait, it's 42?
Yeah.
Oh. Thanks. So I avoid the quotient rule, and it's a lot easier. And tomorrow we get to the fun part. Today's the easy part. The chain rule of the trig. And also factor out the most negative. That's where everybody's like.
Yeah, I know that's the point.
You did?
Now you write this to
You guys tried what's up crazy yesterday?
I got you.
It's because started playing cards, and then the stuff was like, and then everyone was like, yeah, like everyone, and then it's like, Asian, he had an orange shirt in the back. It was Nathan. Are you guys even allowed to do this?
Here, come here.
city.
How bad is tomorrow gonna be? 'Cause I'm not gonna be.
It's gonna be pretty bad, but you pay attention. It should be a fun.
Make a video.
Yeah, of course.